Welcome to ERID Online Academic Igcse Chemistry Topical Questions and Simplified Solution Paper 1 and 2 Multiple Choice Questions. So we are on topic 14 Organic Chemistry and focusing on fuel. So we'll look at a few questions. I want to encourage you to subscribe to my YouTube channel, and of course you can visit www.eridonlineacademic.weebly.com for more videos on various topics and questions and simplified solution. So on fuel, I want to take you through the uses of the various fractions of petroleum gotten after the fractional distillation of petroleum. Of course, you need to recall that petroleum is a mixture of hydrocarbons. Hydrocarbons are chemical substances containing hydrogen and carbon only. So, looking at the various fractions of petroleum, starting from the refinery gas, which has the simplest number of carbon atoms, to bitumen with the highest number of carbon atoms. That's the variation in number of carbon atoms. You can see refinery gas from carbon 1 to 14, to 4 rather, and of course bitumen starting from carbon 50 upwards. Another thing you need to be able to recall will be how does the number of carbon chain affect the boiling point and the viscosity of the various petroleum fractions. So it's pretty very simple. The higher the number of carbon atoms, the greater the boiling point, and the more viscous the petroleum fraction will become. So increase in carbon chain, okay, increases boiling point, and that also means increase in viscosity. Okay, it means that the viscosity will also increase. So that's a very important connection that you need to make quickly. Now, apart from that too, you need to be able to recall the basic principle of fractional distillation. The mixtures in petroleum are separated based on the difference in their boiling point. They are separated based on the difference in their boiling point. And of course, because they have quite a closer boiling point variation, so there's a need for fractional distillation rather than using simple distillation. Of course, you know that simple distillation and fractional distillation are two processes of distilling or separating mixture by distilling. For simple distillation, the mixtures being separated have far the boiling point are farther apart, while for fractional distillation the boiling point are what they are closer, and so there's a need for a fractionating column that will give us the advantage of distance in separating the mixtures containing fractions of closer boiling point. Okay, so the next thing I want you to understand will be finding the mnemonics for you to be able to recall the various petroleum fraction and of course their uses. For the refinery refinery gas, let's just coin a mnemonics. Okay, ga for gasoline, na for naphtha, and of course pa for paraffin. Then for your diesel we have D. Okay, for fuel oil we have fu, and of course for lubricating fractions we have lu, and of course for bitumen we have bit. Okay, that's simple. So let's take it together. Re ga napa, difolubate. Riganapa Difulubit. Riganapa Difulubit. Riganapa Difulubit. Let's go. Riganapa Difulubit. Riganapa Difulubit. You know that's simple, and you'll be able to recall the various petroleum fractions, and now they are actually distilled one after the other. It's important that you know the order, so just use that simple wrap. Riganapa Difulubit. You get you will not be able to mix the fractions up. So the various uses for the various fraction are shown here. So let's quickly see how we can apply this knowledge to solve past questions. Questions on petroleum fractions are really pretty simple, you know. So let's take question 1. The diagram shows the separation of petroleum into fractions. So we can see the various petroleum fractions. You have to look for find you have to find X, Y, and Z. X, Y, and what? And Z. Which could X, Y, and Z represent? So A, we have diesel oil, lubricating fraction, paraffin. So basically, to be able to solve this question, you need to understand the order in which the petroleum fractions were placed. Now, sometimes look at this particular question, you do not have all the fractions shown here, so the sequence will help you to be able to understand the way they are placed. Okay, let's do a quick review. You can see Riganapa Difulubit. Okay, so we have the first one, gasoline. Your gasoline is there. The next one after gasoline should be what? Next one after gasoline, naphtha, followed by paraffin, diesel, fuel oil, lubricating, fraction, and bitumen. But if you look at the three options that we have here, so you may need to just arrange. You have par, which is your paraffin. You have par, your paraffin, okay, par. Then naphtha, diesel, full lubit, Riganapa Difulubit. So you can see there. So we have paraffin followed by diesel and followed by lubricating oil. So your lubricating oil couldn't have come first, couldn't have been X. Your lubricating oil has a higher number of hydrocarbons, so it couldn't have been present here. So B would be a wrong option. Then of course your paraffin is before diesel. Paraffin is before diesel, so A is a wrong option. So we have C and D looking like the right answer here. So check here, your lubricating oil cannot come before diesel, so the correct answer is D. Okay, that's simple. Let's move on to question 2. What is not the correct use for the fraction named? This is a very simple question. So you remember the various uses of the petroleum fraction. Fuel oil is used for what? Fuel oil is used for powering heavy engines, stations, power stations, ships, and for home heating system. Okay, then the other fractions that we have there, gas oil. What is gas oil used for? Gas oil is actually another name for diesel. Gas oil is another name for diesel. Gas oil is another name for what? For diesel. So don't mix that up. Gas oil, another name for what? For diesel. So if you go back to this, kerosene, kerosene is generally used as fuel. Yes, naphtha is used as making what? Chemical. So naphtha is used as for making chemicals. So this is correct, this is correct, and of course this is correct. So A is wrong. Fuel oil is not used for making waxes. So I want to ask you, what is used for making waxes? Yeah, that's lubricating oil. Lubricating oil. That is used for making waxes. So lubricating oil is used for making waxes, not fuel oil. So question 3. Which row shows the correct use of a fraction obtained by the fractional distillation of petroleum? So let's begin to check it. Bitumen is not used for making waxes and polishes. Bitumen is used, for tying roads. Okay, this is not correct. This option is not correct. Fuel oil for aircraft. Aircraft uses what? Kerosene, paraffin. Okay, kerosene for ships. No, kerosene is not strong enough to power. It's not viscous enough, if you like, to power for to power ships. Naphtha is used for making chemical. That's pretty simple. So the correct answer here is what? Is D. Question 4. Which statement about petroleum is not correct? It can be separated into useful substances by fractional distillation. We have checked the fact that petroleum is separated into the various fraction in the fractionating column. Various fraction in fractionating column. So, and what is the basis of that separation? The basis of that separation is what? Fractional what? Distillation. Fractional distillation is used for separating petroleum into its various fractions. Okay, let's look at option B. It consists mainly hydrocarbon. Yes, petroleum is a mixture of hydrocarbon. It could contain some other impurities, sulfur, nitrogen, and all that, but mainly, the key point here is mainly. So this is a correct statement, just like A is a correct statement. So let's look at C. It is found underground in many parts of the world. Here, petroleum is found deposited underneath the ground and attached to be explored through petroleum exploration and oil well to dig it out, and before fractional distillation is done, and post fractional distillation is also done, so that we can get the best out of the various fraction of petroleum. Then looking at option D, its main use is for making lubricant and polishes. So petroleum fraction is used for making lubricants and polishes, but the main use is not for making lubricant and polishes. Okay, it is used for fuel, in homes. It is used for fuel in cars, in powering power stations and all that. So the uses of petroleum or petroleum fractions goes far beyond making lubricants and polishes, and that is actually the use of a component of a fraction in fractional distillation of petroleum, and that is what? Your lubricating oil or lubricating fraction. That is what is used for this. So basically D is not a correct statement. So the answer is what? Is D. Question 5. Petroleum is separated into useful fractions by fractional distillation. Separation occurs in a fractionating column, of course. Yes, some properties of 3 of these fractions are shown. Okay, so we have fraction 1, fraction 2, and fraction 3. Some of their properties are shown, as said in in the question. Some properties are shown, so we may not assume that maybe the question is wrong or something is missing here and here. Okay, so looking at that, we cannot just begin to look for a trend. If you look at the number of carbon atoms, one might want to assume that fraction 3 will have higher number of carbon atom than fraction 2. Okay, but looking at the boiling point, you can see that fraction 2 has a higher boiling point here than fraction 3. So based on that, one would know that the number of carbon atoms, so because the boiling point of fraction 2 is more than the boiling point of fraction 3, one would expect that the number of carbon atoms in fraction 3 will be lesser than fraction 2. Okay, and of course, because the number of carbon atoms in fraction 1 is lesser than the number of carbon atoms in fraction 2, one would expect also far lesser. One would expect that the boiling point will be the lowest, considering the fact that its number of carbon atom is what is far lower. So this will be far less. So let's look at the question and see how it applies. Which statement is correct? Fraction 1 has a higher boiling point range than fraction 2. Higher boiling point range than fraction 2. That is not correct. We have, agreed that the boiling point of fraction 1 will be lesser than what? The boiling point of fraction 2, because the number of carbon atoms in the molecule of fraction 1 lesser than what? That in the molecule of fraction 2. So therefore its boiling point will be what? Will be lower, not higher. So this is wrong. Okay, fraction 2 is removed from a higher point in the fraction taller than what? Fraction 1. If fraction 2 has a higher boiling point than fraction 1, then therefore fraction 1 will be removed from a higher point in the fractionating column than what? Than fraction 1. Okay, if you look at the fractional distillation, okay, of petroleum, look at this diagram. Fractions that are lower have, higher boiling point than fractions that are that are at the top. So fractions that are removed at a higher point have far lower boiling point. They have lower boiling point than fractions that are removed at the later lower part or lower point. So these ones have what? Have higher boiling point. So it's like, opposite. Fractions with higher boiling points are removed at lower point, while fractions with lower boiling point are removed at what? At the higher point. Did you get that? Okay, so let's go back to our question now. So option 2 is also wrong. Okay, molecules in fraction 3 have shorter chains than those in fraction 2. Okay, molecules in fraction 3 have shorter chains than molecules in fraction 2. Okay, we've looked at that via explanation that they have lesser number of carbon atom than what? Than fraction 2. So that means they have lesser chain, and that is why they have lower boiling point than what? Than fraction 2. Okay, so fraction 3 have lesser number of carbon atoms. They have lower boiling point than what? Than fraction 2. Okay, C seems to be a correct option, but let's consider option D so that we can choose the most appropriate option. None of the fractions is liquid at room temperature. That can be correct, because we're giving their what? Their boiling point. Okay, we have their boiling point. Now they are asking us that none of the fraction is liquid at room temperature. So okay, so if you look at that, their boiling point is far higher than what? Than room temperature. Room temperature is just around 25 degrees Celsius. Okay, so if something has a boiling point of 120 or 350, definitely at room temperature that particular substance will still be what? At 25 degrees Celsius before it gets to its boiling point. In between, it will still be what? It will still be a liquid. In between, it will still be a liquid, because this is room temperature. Room temperature is far lower than its boiling point, so you would expect it to still be a what? A liquid. So it's possible that some of these fractions are liquid, are what? Or gas at room temperature. So the correct answer here is what? Is option C. I hope you've learnt in this video about how to answer questions with respect to fuel and the use of petroleum fraction. I will see you in volume 2.